In order for somebody to play our game, we need to have a way of detecting what buttons they're pressing so that they can interact with the game. To do that, we're going to have to add some code that defines a little bit more about how the circuit works, specifically how the buttons are attached to it. The first step is to create another variable. I'm going to create it right here, and I'm just going to say byte button. Now, this gives us a place to store information about how a button is attached to our circuit. Down here, we need to actually tell it for each specific color, where is the button attached. So the very first number here tells us that the LED is attached to pin 10. The second number needs to tell us what the button is attached to, and I can see here that the button is attached to pin 9. So I'm going to put a 9 here, and then we have the frequency. And the reason that it's in this order is because here we have the LED, the button, and then the frequency. We need to have the LED, the button, and then the frequency right here. It needs to be in the same order. We need to do the same thing with the green colors. So the LED is attached to pin 7. The button is attached to pin 6. So I got a 6 right there, just like the button is attached to it right here. And then the frequency for the green color. Once you've done that, we need to actually set the pin modes for the buttons as well. So down here, right below the setting the LEDs, I'm going to go ahead and set pin mode for the red button to input pull up. And I'm going to do the same thing for the green button. Once I've done that, I'm ready to go ahead and start creating a function that listens to the buttons. So at the very bottom here, I'm going to create a new function. And uh, it's going to be different than the functions we've created previously where they're all void. This function is going to be a char, which means it's going to return a character. These functions, when they run, our program calls them, it goes and does whatever instructions are inside the function, but it doesn't get any information back from them. Our button pressed function is going to return a character that tells us whether we pressed the red, the green, the blue, or the yellow button. I'm going to call this function button pressed. It's going to have a series of if statements that check for each button. The first one is going to say digital read, and then we're going to read the red button. And if the red button is equal to a 1, it turns out that it's not pressed. It's when it's equal to a 0 that it's pressed. If it's equal to a 0, if it's pressed, then I want to blink the red LED. So I'm going to say red dot blink. I also want to return an R. I'm going to do the same thing for the green, except I'm going to put else here. If I have just a series of if statements, it would work, but if I put else if, then as soon as this statement resolves to true, or if this statement resolves to true, then it will skip the rest of them, and it'll make our program run just a little bit faster. But the condition is the same, digital read green button equals 0. And if that's true, then we want to blink the green LED. I'm using single quotes here because this is a character data type that it's supposed to return, and the single quotes make this a character. If we use double quotes, that would be a string, and that wouldn't be compatible with the type of function that we created here. I'm going to create one more condition here, and this is just going to be an else. And we're going to say if none of these things are true, then I want to return an N. That means no button was pressed. Okay, it's time to test out our code. I'm going to go scroll up to our loop, and I am going to type button pressed, and I want to print that to the serial monitor. So I'm going to say serial dot print ln, and put a semicolon there. I'm also going to give myself a little bit of a delay here because this is going to run so fast. We're going to see so many characters flying through our screen that it'll be hard to see what's going on. So if I put a little delay in here for just 500 milliseconds or half a second, we'll be able to see whether it's actually working or not. So now I'm going to start the simulation. And I'm going to open my serial monitor, and I see a bunch of N's showing up on my serial monitor. Now, if I press and hold the button for the red LED, I see an R show up, and you saw it light up and heard it beep. If I do the same thing for the green button, I see a G show up. I saw it light up, and I heard it blink. So our code is working just like it's supposed to. One thing to keep in mind is you can't just click the button. If you click it for just an instant, it will probably get skipped over here because you've got to remember that this delay is causing our program to ignore everything that's happening for half of a second. If you hold this button for at least half of a second, then you're guaranteed that the loop will run this command while you're holding the button, and it will actually work. You'll see the R show up down here, and the button will light up and it'll make the beeping sound. Once you've added this functionality to your program, go ahead and commit your code to Bitbucket, and then add the code necessary to detect button presses for the blue and the yellow buttons. Then, once you've added that functionality and you've tested it and you've made sure that it's working, make another commit to Bitbucket. Your commits should have keywords in them that are talking about buttons being pressed and explaining, is it only working for the red or green LEDs, or is it working for all of the LEDs?